Thanks a lot. Thanks so much for having me. Yeah, so this is Can Incentives Cause Harm? Tests of Undue Inducement. And I'm going to present experiments that I've conducted over multiple years. The motivation is that around the world we have laws and guidelines that limit the incentives that can be paid for transactions such as organ donation, surrogate motherhood, human egg donation, or participation in medical trials. And these limits are often, they're just limits. So often these transactions, if you don't take any money for it, you're allowed to participate. And one of the main reasons why we have these laws is what's known as the undue inducement doctrine. It's a vague concept. And the Stanford Encyclopedia of Philosophy defines it as a term of art, meaning that something is being offered that's alluring to the point that it clouds rational judgment. Attention is fixated on the benefit, disallowing proper consideration of risks. So the idea is if I offer you a lot of money for doing something, I somehow mess with your thinking and thereby I cause you to make bad decisions. In fact, the American Society for Reproductive Medicine, they are a bit more specific. They say payments to women providing human eggs should be not so substantial that they lead donors to discount risks. The higher the payment, the greater the possibility that women will discount risks. And so they then decided no American woman can take more than $10,000 for donating eggs. That's been struck down in court based on antitrust grounds, but these types of arguments are quite frequent. Now, if you look at this hypothesis, it actually has two parts. One is a behavioral prediction, which is if we pay people more money, or we promise them more money, they look at the transaction differently. They process information in a biased way. And the second part is a normative stance, which says, and therefore, or it says this biased information processing or selective information processing is bad, and therefore we can allow low incentives, but not high incentives. Well, maybe that's right. Maybe it's wrong. We don't have any evidence. And that's the evidence I want to provide. So I want to first look at how participation incentives change, how and what people learn about a transaction. And then I want to look at whether these effects, if we do find behavioral changes, justify putting caps on incentives. To do that, I'm first going to do an experiment with a quite visceral transaction. So people's emotions are going to be involved. Then I show you a very simple theory that shows what we should expect from rational people, how they should be affected by incentives. And then I'm going to do some more experiments to explore the robustness across many dimensions of the results I have. So the first experiment, I want to incentivize people for doing something they don't like. And I want to see whether if I offer them higher incentives, they make worse decisions. So the transaction I seek is one that should be aversive. It should be unknown to subjects, and it should be one where they can, if they want, selectively acquire information about. So I have something that looks like discounting risks. So what I do is this. I pay people actual money to make them eat actual insects. And the way it works is when you come into the lab, you learn you're going to be offered $3 if you agree to eat the insects. Other people learn they're going to be offered $30 if they agree to eat the insects. And I want to see whether the incentive changes the quality of decision making, and also whether it changes how people want to inform themselves about what this thing is going to be like. So before they learn anything else about the insects, and before they decide whether they want to eat them, they can watch one of two 6-minute videos. They can decide which one they want to watch. One is called Why You May Want to Eat Insects. The other is called Why You May Not Want to Eat Insects. And the hypothesis is that if I offer people higher incentives, people become less interested in learning about the downsides and more interested in learning about the upsides. Just to have more statistical power, I also split these videos in small clips. Some of them called reasons for eating insects, some of them called reasons against eating insects, and other neutral ones. And you have to select at least 4 of them. After you have selected the information and you have watched the videos, you decide, do you want to eat 5 roasted whole large mealworms in exchange for the incentive I have promised you in the beginning? So people do that. And then the experiment has additional stages that I'm going to tell you next. But I did these experiments with about 700 undergrad students at Ohio State. And let's see how incentives affect how people want to learn about what the transaction is going to be like. What I'm plotting on the y-axis here is the percent of people selecting the positive video, why you may want to eat insects, as a function of the incentive. And you can see that if we provide a higher incentive, people become more interested in learning more about the upsides, because they can select only one of the 2 videos. That also means they less often see the video highlighting the downsides. And you can also see, when you look at of these pro and con clips that people can select, we offer a higher incentive. People select a larger number of pro clips and a smaller number of con clips. So incentives cause biased information acquisition. Now, this biased information acquisition, one thing that could cause that is that once you learn about the incentive, you already decide, are you going to do this thing or not? And then based on that decision, you just select whichever video makes it easiest to follow through with that decision. To show that this is not the case, to show that the information has an effect on people's eventual participation decisions, I also have a condition where people cannot see a video at all. And I'm plotting on the y-axis the fraction of people who agree to eat the insects for the promised incentive. And you can see that if there's no video, participation goes from like 35% up to just under 60%. But if people in a high incentive condition have access to this encouraging video, which they often select, the incentives have a stronger effect. So the information affects the probability with which people participate. And that all resonates with this prediction of the ethics literature that higher incentives somehow change information processing. It leads donors to discount risks. The higher the payment, the greater the possibility that women will discount risks. But this is just a behavioral effect. What about, are these decisions good or bad? So are there actually welfare functions such that we would want to allow the transaction at the low incentive, but prevent it at the high incentive? Now, to answer that question, I need to know something about people's utility from eating these insects. What I do is, so far, people have made the participation decisions just based on the video they've seen and on a verbal description. That's quite sparse information. Now I'm going to hand out all the insects and I force you to interact with them. So there's a little code in each container underneath the box that you have to take out and put into the computer. So you smell the insects, you touch them, you see them. Might be these 2 field crickets, these mealworms, these house crickets, these silkworm pupae, or these mold crickets even. They smell quite strongly, partially because they were expired, which I only learned after the experiment. But I hand out these insects and then I ask people, well, now that you have all of these additional information, what's your actual reservation price? So you're going to make a sequence of additional decisions, and one of them might be implemented at random. So the first decision is, would you eat these items for free? Maybe not. Would you eat it for $1? Maybe not. But as I go up high enough, maybe you start saying, yes, I'll eat them. in exchange for that amount. And the point at which you first say, yes, I'll eat them, that's your reservation price. That's a measure of how bad you think eating these things is for you now that you have all this additional information. So with that information, I can basically plot this demand curve, right? And so I can calculate Marshallian surplus of people who agreed to eat the insects at the promised incentive. So if you said, I will eat these things at $30, and then later in the multiple decision list, I see your reservation price is just $20, well, your surplus is $10. You got $30. You would have done it for $20, so you have a surplus of $10. It's also possible you made a mistake. It's also possible you said, yes, I'll do it for $30, but then your reservation price is $60, and so you've just lost $30 in surplus. And so what we can do is simply plot the cumulative distribution of surplus. Now you can see that in the high incentive condition, most people who agree to eat the insects have positive surplus, and about 10% have negative surplus. So their surplus is to the left of zero. And in the low incentive condition, a lot of people say don't eat them at all, but of those who do, about 20% eat them, and they have positive surplus. A bit lower than 20% eat them, and they have negative surplus. So what does that mean for whether offering a higher incentive is good or bad for these subjects? Well, we see basically a first-order stochastic dominance shift in terms of surplus as we offer higher incentives. Yes, it's true that some people make mistaken decisions. They have negative surplus, they expose regret, but the fraction of these goes down as we increase the incentive, and those who don't have negative surplus, their surplus increases too. So if you have any welfare function that's increasing in individual surplus, that welfare function will say offering $30 is better than offering $3 to these subjects. So even though the incentives change how people want to inform themselves about the transaction, there are no identifiable negative welfare effects of that. Yeah, and then you can have all kinds of critiques about this finding. One possibility is that these surplus curves, they rely on me measuring your surplus, but maybe the video that you've seen or the incentive amount I've promised affect what you say is your reservation price for eating these insects. So one thing I can do is to say, well, hypothetically, for everybody who saw a video and got the high incentive, let's not use the demand curve or the willingness to accept data that they've given to us. Let's instead replace them with the willingness to accept data from the people who didn't see a video and were in the $3 treatment. Let's use those willingness to accept measures for everybody, and let's see whether in that case, where the information and the incentives can only affect the participation decision, but not the distribution of valuations, whether then we get negative welfare effects. Well, we don't get negative welfare effects in that case either. Now, so this is basically what this experiment shows so far, is that the behavioral predictions of the undue inducement hypotheses are vindicated. We do see that higher incentives change information acquisition, but the normative implications are refuted. We don't see that higher incentives lead to worse decisions in a way that would allow us to say you should allow the low incentive, but you should prevent the high incentive. Now, why is that? How do we get this disconnect? Well, one way to explain that is to study if you're a perfectly rational decision maker, perfectly Bayesian, and you can decide whether you want to participate in a transaction that you first have to learn about a little bit. How would incentives affect you? And of course, we cannot make a Bayesian decision maker worse off by offering higher incentives. So how would you decide when you have to learn about the transaction? Well, if processing and acquiring information is costly for you, you're going to have to decide on partial information, which means that you're going to make two possible mistakes. One mistake is that you participate, even though if you had full information, you would have abstained. The other possibility is that you abstain, even though under full information, you would have participated. So you have these two types of mistakes. And well, why do you want to acquire information? You don't want to make these mistakes. And so if you only have so much resources you can spend on information acquisition, well, what type of information do you spend them on? You want to spend them on the information that helps you make the more expensive mistake less often. Now, if I offer the incentives that I offer you for participating in a transaction, they determine which type of mistake is the more expensive mistake. So if I just offer you a low incentive for doing something you probably don't like, you don't know it quite yet because you don't have the information, but if I just offer you a low incentive, then the expensive mistake is to say yes by mistake, right? You have little to gain, the incentive is low, but potentially have much to lose. So you want to make sure you don't participate by mistake. So you're going to look at discouraging information, mostly discouraging information. If I offer you a high incentive, now I've changed the relative benefits and costs of information of the mistake. So if I offer you a high incentive, you have a lot to lose from saying no by mistake. You're forgoing a large incentive. And you have less to lose from saying yes by mistake because you receive more money, even in the bad case. And that's why, with a higher incentive, you want to bias your information search pretty much in the way we've seen in the experiment. Formally, what you want to do is you want to consult information sources that have a higher probability of telling you, yes, you should participate in the transaction. So this is what this toy model, there's a formal model in the paper. What this model shows is that the behavioral prediction of the undue inducement hypothesis, that incentives change how you want to inform yourself, is potentially entirely rational. And because of that, it's not an implication that changes in information acquisition should make people worse off. In fact, in this case here with perfectly rational subjects, the changes in the mistake in the information acquisition actually make people better off. Yeah, so that's what we get from this theory. A higher incentive causes information search to be biased towards participation. And another thing that also comes out of the theory is the second graph that I've shown, that when you allow people to tailor information acquisition to the incentive, an increase in the incentive is going to have a larger effect on supply than when you don't allow people to tailor information acquisition to the incentive. Yeah, so this is the simple theory, and now we can. I want to do a second experiment. And the reason for that is manifold. One reason is just because you can explain some kind of empirical finding with a rational model, that doesn't mean that the rational model is actually the right explanation. So this is one thing I want to see to what extent this information acquisition behavior by people is actually rational. I also want to be able to use different welfare benchmarks. So in the case with the insects, I've used an ex post welfare benchmark, right? You made a decision, and then I looked at ex post, having the information you now have, but didn't have when you made the decision. Was your decision good or bad? But just whether a decision turned out good or bad after the fact doesn't mean that this decision was good or bad ex ante. So I want to do an experiment where I can do welfare calculations using an ex ante benchmark, seeing whether people actually maximize expected utility. Now, the exposed benchmark is actually, it's not just convenient, it's also the way the ethics literature often works. So exposed benchmarks, they're defined on exposed outcomes, but then you have to say, well, you got a large number of exposed outcomes. How do I translate that into whether the decision was ex ante good or bad? Well, the way you do that is to say you have to aggregate these outcomes in some way. And that aggregation typically relies on some external judgment of what is good or bad, or what fraction of bad outcomes is reasonable. And so to do that, the ethics literature often relies on what's known as the prudent person rule. It's also a very common concept in law, but the prudent person rule says, well, these are rules expressing how ordinary or average or prudent persons would view the offer. But that's not how we usually do things in behavioral economics or in economics more generally. We use ex ante welfare, which is whether the person themselves maximize their utility at the point of making the decisions. So this is what I want to do, what I want to be able to do in this second experiment. Judge the quality of decisions as a function of incentives using the ex ante benchmark. The second thing I want to do is I want to test the robustness of the experimental findings.
Can I make a clarification question with your definition of welfare?
Absolutely.
When I think of the motivating example that you provided in the beginning with the egg donor, then the welfare should affect both partners. But in your experiment, you are paying the subjects.
Yes.
So the costs are very different if you pay them 30 or 3.
Yes.
And this seems to be neglected in your definition of welfare.
That is entirely correct, yes. The reason why I'm doing this is because I'm talking to this literature on undue inducement, which only considers the person who receives the incentive. Now, if you also consider the other side, the person who can now have a child because there was an egg donor, the case for incentivizing becomes just much stronger. So basically, my experiment is biased towards finding evidence consistent with the ethicist's stance, because I'm neglecting the welfare benefits to the other side. Does that?
No, but I mean, you could also argue that well. So here you would say it's welfare improving if you give them the $30. But if you just focus on this group, then you could say, well, so this is our society, but the $30 have to come from somewhere.
Yeah.
And if they have to finance them by themselves, then perhaps your welfare comparison would look very, very different.
Yes, no, that's right. That's right. So often these discussions on preventing market transactions or limiting prices, you're preventing, say, couples who want to get pregnant from offering that amount of money. Mm-hmm. So these couples already reveal that it would be worth to them. They would be willing to pay much more. They're just not allowed to do that.
Mm-hmm. Mm-hmm. Okay.
Yeah. But it's entirely right. I'm just focusing on the person who supplies something here. Yeah. One thing that I want to test the robustness of my findings to is delayed consequences. Because when you face benefits of a transaction in the present and all negative consequences might only apply in the future, maybe this disconnect is one of the reasons why you're making bad decisions. And maybe that gets magnified if the incentives you get at the present are higher. So I want to have a treatment where I delay negative consequences. I also want to see whether things vary as I change the stakes, as I go into a higher stake setting. And in this experiment, we're going to have a one-to-one mapping to the theory. The way the experiment works is there's a subject who, the way I framed it, is decides to participate in a venture. And if you participate, you receive incentive M. If you don't participate, you receive nothing. The venture is successful with some prior probability that you know. If the venture is successful, you keep that participation payment. The venture might also fail. If the venture fails, you don't get the participation payment, and you also pay damages. So you want to participate in successful ventures. You want to abstain from ventures that will fail. Before you decide whether you want to participate, you can consult one of two advisors. These are just stochastic information structures, but this is a screenshot of how I present this to the subject. So this is from the high stakes treatment. So you're now deciding whether you want to participate in a venture, which if it succeeds, you get 80 euros. If it fails, you don't get the 80 euros, and you also have to pay $100, which comes out of your completion payment, which is $120 or something like that. Now, before you decide whether you want to take that venture, you can either get advice from the bold advisor or from the cautious advisor. The bold advisor, if the venture will succeed, is certain to tell you so. The problem is that if the venture will fail, there's still a 50% chance that the bold advisor tells you take it. So the bold advisor comes with the risk of making a false positive mistake, of participating by mistake. The cautious advisor is the opposite. If you're looking at a venture that will fail, the cautious advisor certainly tells you so. The problem is that even for ventures that will succeed, there's a 50% chance that the cautious advisor tells you not to take it. So the cautious advisor comes with a risk of false negative mistakes. Okay, and now we can see how the incentives, so this participation payment M, I'm going to call that incentives, how that affects people's choice between advisors. So you first learn how much money you get, then you select an advisor, you see the advice from the selected advisor, and then you decide whether you want to participate or not. Okay. So, yeah, the data I'm going to show you are from the University of Cologne. Obviously, I have only a few subjects in the high stakes condition. The parameters in the high stakes condition, the damage you have to pay if the venture fails is 100 euros. The payment you can get is 20 euros, 30 euros, 70 euros, or 80 euros. So I vary that. People do this, make these decisions several times for different parameters. And sometimes people ask, you know, why would you want to take a venture where you can win $20 but lose 100 or more? Well, the thing is that the advisors give you information, right? So conditional on receiving a good signal, you might want to take the incentive. You might want to take the transaction even if the payment is only $20. In the regular stakes condition, the damages are only 6 euros. The participation payments range between 1 and 5 euros. And this is where I do all the treatment variation with the different priors, delayed consequences, and things like that. Okay. So how do incentives affect information choice? Exactly as predicted. So this is from the regular stakes condition, but you see the same effects in the high stakes condition. If the incentive amount is low, people are wary of saying yes by mistake. They want to make sure they don't say yes by mistake, so they often go for the cautious advisor. They don't often select the bold advisor. And if the incentive gets high, they select the bold advisor much more often, exactly as predicted by theory. We also see that this information affects how people eventually decide, also as predicted by theory. So I have two conditions. The one I've explained to you is the case incentive first. You first learn the incentive, then you select your advisor. So you tailor your information acquisition to the incentive amount. The control condition to that is you first choose an advisor and only then do you learn the incentive. You cannot tailor the information acquisition to the incentive amount. And as you can see, if you are able to tailor information acquisition to incentive, you get a stronger response in supply to any given increase in the incentive than if you cannot tailor your information acquisition to the incentive, also as predicted. So again, this confirms the behavioral prediction of the undue inducement hypotheses. Higher incentives change how people want to inform themselves. They much more often go for the bold advisor that more often tells them yes, even sometimes by mistake, than if the incentive is low. What about welfare? So now I have a slightly different way of measuring welfare. And the idea is, let's look at where mistakes can come from in this setting. And of course, the most difficult part of this setting, once you've selected an advisor, is to know what really is the chance that I'm going to win if the bold advisor tells me take it. So just as an exercise for you theorists, maybe you can see that right. Maybe you can see that quickly if you have a prior of 50-50. Yeah. So if you have a prior of 50-50, right, and you get the good signal, then there's a 2/3 chance that the state is good if you receive a good signal, and you've asked the bold advisor. But maybe regular subjects, maybe they don't see that. Maybe they ask one of these advisors, get a signal, and then they're completely mistaken. They're maybe totally overconfident about how likely it now is that they're facing a venture that's going to succeed. And so these misperceptions are what could drive welfare losses in this setting. Now, formally, when you're a subject in this experiment and you've just received the piece of information, you're now facing a lottery where you can either win the incentive or you can lose the damages you have to pay. And the lottery you're actually facing, that's the Bayesian posterior. That's if you've received a good signal from the bold advisor, gamma is 2/3. But it's possible that you believe that if the bold advisor gives you a good signal, that then the probability of success is 90% rather than 2/3. And if you're overconfident in that way, maybe you're going to say, yes, I'll participate in the transaction, even if you would have rejected it had you known the prior is only 2/3. So what I can do experimentally is I can ask you, suppose you saw you selected the bold advisor, you saw a good signal. Unbeknownst to you, that means you faced a 2/3 chance of winning. So I can ask you, would you rather play this lottery, 80 with a 67% chance, or lose 100 with 33% chance, or would you rather lose 15 for sure? And if you were super overconfident, and that's the reason why you accepted the gamble, you thought the probability of winning was 90%, You might still say, well, if the probability of winning is only 67%, I actually rather like to lose 15 for sure. So then I know your decision to participate in the gamble was a mistake. If I ask you this question for a range of comparison amounts, would you rather take the gamble or lose 15 for sure, rather take the gamble or lose 10 for sure, rather take the gamble or lose 5 for sure, and so forth, I can elicit your certainty equivalent. I know exactly how much the gamble that you have actually taken was worth to you. According to your own utility function, I see your certainty equivalent. So for any decision you made in part 1 of the experiment, select an advisor, receive a signal, decide to participate. For any such decision, I elicit your certainty equivalent. And I can now look at what fraction of these decisions were mistakes. And how does the distribution of these mistakes change as we change the incentive amount? Okay? And just for simplicity, I pool the 70 and 80 euro amounts into the high incentive condition and the 10 and 20 into a low incentive condition. I define individual welfare from accepting the transaction as the subject certainty equivalent if they participated, and 0 if they abstained. Okay. Yeah, and so you can see that the blue line is the distribution of these certainty equivalents when the incentive is high, and the red line is the distribution of certainty equivalents when the incentive is low. I no longer get a first-order dominance relationship. It is now the case that with higher incentives, there's a little bit more mass on the left of 0. So we get worse decisions for some people if we offer them higher incentives. That's probably the people who were induced to choose the bold advisor by the high incentive, but who then became overly confident after seeing good signal and thereby participated in transactions that were more risky than they thought. But you also see that a lot of people benefit from the higher incentive. So now it's less clear whether in a setting like this, you would want to say, let's allow the transaction, but only for low, not for high incentives. Let's see whether it's actually plausible that you would ever want to make that statement. To do that, I'm now going to consider a family of welfare functions. So I'm going to say there's a social planner who evaluates welfare by taking your certainty equivalent and putting it into some function and aggregating these weighted certainty equivalents. Because the undue inducement literature basically distinguishes between those people who are harmed and those who are not harmed, I'm just going to say, I'm going to put weight alpha on those who are harmed and 1 minus alpha on those who are not harmed. And the question is, given these data, can we find a welfare weight alpha such that we want to say we should allow the transaction for low incentives, but prevent it for high incentives? Is it possible to say that? Well, let's think about it. So now I'm going to say UIC normative. That's so the normative part of the undue inducement condition. Allow it at the low incentive, prevent it at the high incentives. So to allow it at the low incentive, your welfare weight on the losers must be low enough, right? Even at the low incentive, there are people who say, yes, I'll do it, but they lose welfare from doing so. You're only going to say it's okay to allow this transaction at the low incentive if you don't care too much about the losers. Now to say, let's prevent the transaction at the high incentive. We know we have more losers at the high incentive. To say, but we also have more winners at the high incentive. So to say, let's prevent it at the high incentive, you have to put enough weight on the losers, right? And so it's only possible to find a parameter where you want to allow the transaction at the low incentive, but prevent it at the high incentive, if these bounds are in the right relation, that the lower bound has to be lower than the upper bound. If there's something in between these two bounds, then yes, for that parameter, you want to say, let's allow the transaction at the low incentive, but not at the high incentive. But if the lower bound is higher than the upper bound, it's not possible. Then you want to say, either allow the transaction for any incentive or prevent the transaction for any incentive. And well, if we look at the data, if we plot the average gain of the winners in blue and the average loss of the losers in red, the black dot is where you are if you weigh them 50-50. If you want to say, let's allow the transaction at the low incentive, then you have to say, we can't put more than 0.47 weight on the losers. If you put 50% weight on the losers, then you're at the black dots. You're below zero in terms of overall welfare. It's better to prevent the transaction at the low incentive. If you want to say, let's prevent the transaction at the high incentive, you're going to have to put a lot of weight on the loser because the gains to the winners are quite large. So if you want to say, let's prevent the transaction at the high incentive, you have to put at least 0.68 weight on the losers. And obviously, you can't find an alpha that is smaller than 0.47 and larger than 0.68. So clearly, it's impossible to find welfare weights such that you want to cap incentives. Yeah, so that's the main result from this experiment about the normative part of the undue inducement hypothesis. And then you can ask, well, how robust is this? And you get the same result, the same violation, both for the regular stakes condition and for the high-end stakes condition. I've shown you the data from the high stakes condition. What I've shown you is what happens when any loss you incur is incurred immediately, but I also have a condition where any gains are paid out to you immediately, but you receive a part of your completion payment only with a 3 months delay. And if you incur any losses, the losses are taken out of that delayed completion payment. So that delay treatment doesn't affect things either. So we also get a violation of the undue inducement condition, the normative part. And then you can say, well, I've done everything with a 50% prior success probability. 50% is much easier to apply Bayes' law than if you have something like 20% or 80%. Kahneman and Tversky have shown us that with the Bayes rate neglect studies. But even if you have these much different prior failure probabilities, you still don't get the normative implication of the ethics hypotheses. And also, if you rather than doing ex ante welfare analysis, you do ex post welfare analysis, you also don't get support for the normative part of the hypothesis. So that's basically what I have. So let me summarize the whole story. The undue inducement hypothesis, that's the reason why you cannot sell the kidney, or in many countries why you cannot take money to donate human eggs and so forth. The fear is that high incentives somehow cause people to make bad decisions, whereas low incentives wouldn't. If you look at the hypothesis in detail, you see there are two parts. One is a prediction about how incentives change behavior and information acquisition. We have found evidence for that in 2 experiments, and I've set up a model that shows that this is exactly what you should expect from rational Bayesian subjects if information acquisition is costly. But the normative part of the hypothesis, that because incentives change information acquisition, you should only allow low incentives but not high incentives, there's no evidence for that in any of the experiments or any of the treatments that I've shown you. This is really quite robust according to both benchmarks, welfare benchmarks I can use, low stakes, high stakes, money only, involvement of visceral transaction, delayed consequences, various priors, and so forth. Now, of course, these are lab experiments. You can't now go and say we should allow people to sell their kidneys, but at least you should question some of the arguments on which the current regulations rely, and perhaps design research in these more applied fields to see whether similar results would also apply in the actual market for donor eggs and medical trial participants and so forth. And perhaps one more thing I can say about this is, in case anybody with an ethics background is listening, this is of course entirely consequentialist. I've used, it's just about the outcomes, but one thing I cannot address is if there's a value to autonomy, and if you say incentives decrease somebody's autonomy, I just cannot talk to that with that experiment. Yeah, so that's what I have so far. I do have more research on the topic, which I list here. So in one paper that's coming out in Restat actually, what we show is that participation payments don't only change individual decisions; they also change what selection of people you get. In particular, with higher incentives, you get a selection of people who finds it more difficult to inform themselves about the transaction. And then we have a bunch of research on what do people think is good for others. So what are the welfare functions they think we should impose when doing this analysis, some of which you might have seen in this seminar a couple of weeks ago. Yeah, and I'm happy if you have any questions. Yeah, Arel?
Can you hear me?
Yes.
Okay. Thank you for the good presentation. I have a practical question.
Yeah.
The experiments you showed about the lottery or the venture participation or the insect eating,
yeah,
are they able to transfer to these complex use cases you have in the introduction, like organ donation, clinical or pharmaceutical trial? Because to my practical view, these are very complex situations in the ex ante. There is no full information independent from the incentive you give to the people. How can I see you said it, the delayed consequences or the long-term consequences of an organ donation or a clinical trial? So this is very not easy for a participant, for a prospect in ex ante to get the information independent completely if you have high incentive, low incentive, or any incentive. To my point of view, have you considered
yes,
the complexity of the transaction? Insect eating, to my point, is not very complex because the maximal damage for me is a rough estimation. I eat an insect and maybe I have a little bit sickness, but that's okay. For $60, it's okay. But if I donate an organ or use a clinical trial with maybe long-term consequences and delayed consequences, as you said, that's not so. I cannot compare with the other one.
Yes. So two responses. One, the undue inducement hypothesis is a general statement about human cognition. I'm testing how humans work when they're facing a setting where there's imperfect information.
You're at Plumless Obstrus 10, Zurich, Canton of Zurich.
I don't know what that was. So Siri, okay, sorry, Siri somehow took my voice. I'm sorry about that. So what I think this is a general statement about human cognition, and I'm testing that general statement about human cognition. And the context is you have a transaction with uncertain consequences that you can learn about, and you can decide in what way you want to learn about. It's right that I don't have external validity to these settings like kidney donation and so forth. There might be many other things going on there. But the cognitive basis on which this hypothesis relies, I find evidence against that. Just because the type of information biasing that seems to be going on is almost entirely rational. It's not the case that the incentives cloud rational judgment in a way that cause people to suffer from higher incentives. Mm-hmm. The other thing I want to say is that, yes, it's true. You never have perfect information about what it's going to be like to live in a single organ. Nobody has that information. But in this case, imperfect information, you can just view that as how far are you in your understanding compared to a professor of nephrology, compared to somebody who does this professionally, compared to the best information there is, basically. So I think it's, I don't think in order to apply these findings, it needs to be the case that you can perfectly foresee the consequences. It's only just about how far are you from the best understanding.
Yeah. Okay. I understand it. Well, of course, the experiments you showed are, for me, understandable and intuitive. But for example, the clinical trial, I remember my studying time. They were always offering a clinical trial for students, for healthy students, and they offered thousands of euro. But the nature of a clinical trial is that you have no information ex ante, and the reason for a trial is that you have information afterward about the prospects or the participants, how the medicament or the treatment has affected. This is the nature of a clinical. So it's not so easy to compare with like insect eating. I just polarize a little bit, but you know what I just want to say.
Yeah, I know. I have given this presentation many times, and so this is clearly a point that often comes up.
Okay, thank you.
Yes.
I think in some of the discussions you mentioned with kidneys, it's often the question of no incentives versus incentives at all, and you compared low versus high incentives. I think it doesn't make a difference in your theory, but would you think it does make any difference to your argument?
So it's hard to say what no incentive is. If you look at the discussion on kidneys, one of the questions is, well, so if we reimburse you for the expenses that you have, is that an incentive or not? And then there are like medical trials that should be, they're basically targeting the salaries of low-wage unskilled workers. So first, I think it's hard to say what is a well-defined zero. And second, I think there are many cases in which there are positive but low incentives, like 10,000 for the egg donors as well. Whether zero would be totally special, I don't know. The reason why I didn't do a zero incentive is because in my transactions, I think it's just very unlikely that people would want to participate even for a zero incentive. Ariel?
Okay, I have one remark additionally. For the lottery example, I just make an hypothesis. The lottery example, the incentive could be maybe just to lower the first hurdle to cope with the transaction.
So what could be the incentive?
To lower the first hurdle for a person to cope with the issue or with the transaction. If I see this advertisers, you take this lottery, you will, the first $10 are for free or whatever from your bet, for example, betting companies. And then this is, I think the incentive could just lower the first hurdle, but maybe just don't influence so significant the information seeking. Could be this something we have maybe in your work seen that just the incentive is to lower the first hurdle to cope. If I don't see this incentive, for example, I pass away this offer. And if I incentive, you get my attention just for attention seeking and nothing more. Could be this one thing.
So I have done a version of the lottery experiment where I do find something like this. Yes. So it's basically if the incentive is too low, people don't even care, don't look at the information at all. And as the incentive gets higher, they start to look into it. And in that version of the experiment, I actually don't see so much in terms of getting a different kind of information. So in the lottery experiment, right, this is the choice of the bold advisor. This is what kind of information do you choose? In this additional experiment, I don't see so much an effect on the kind of information. I see an effect on the amount of information, precisely as you hypothesize. If the incentives are large enough, you start looking into this seriously. About medical trials, though, the regulation on medical trials is that they are only allowed to compensate for inconveniences, but not for risk.
Okay.
And that's precisely because of these undue inducement ideas. And if you look, that's a paper by George Lowenstein and co-authors. If you look at what do people infer about what a trial is going to be like, of course they infer if it's more highly paid, it's more risky. But that's not true. It's not allowed to be the case. And that's why these regulations actually cause bad decisions.
Yes, yeah. That's a good point. If I remember these offers in the university for this medical trials for the students, and they offer really explicitly thousands of euro, then this could be not an incentive and not to go to this trial because, as you see, intuitive, logical conclusion could be, 4,000 euro, this could be highly risky,
yes.
and long-term consequence, negative consequence. This must not be positive too. Of course, you are right.
Yes. No, and that discussion also comes up with the vaccine incentives, right? Should we was very prominent with COVID, right? Should we pay people to get vaccinated? And we pay them more. Does that signal that this is a bad thing to do? My colleague here, Florian Schneider, has done experiments on that, and this doesn't seem to be the case. You get very little of that kind of crowding out, at least for COVID vaccines in Sweden.
Yes, okay, but in the vaccination you have the external effects. You can price the external effects like in the medical trial too. Not your own risky, but the external effect for society, the welfare effect.
That's right. You can price that in, but I don't think people understand that, and so it would affect their inference about the vaccine.
Yeah, you're right. Thanks.
Yeah, thanks a lot for the invitation and for the comments.